So when you have any point on the coordinate plane, you must find your r. That is Pythagorean theorem. A squared plus b squared equals c squared. R being that c value. So you can just remember it's the square root of the sum of the squares. And then you have a sine, cosine, and tangent based on your y over r, x over r, y over x. If you remember those three and which ones are the reciprocals, remember the reciprocal of sine is cosecant, you would just flip that. The reciprocal of cosine is secant, you would flip that one, and the reciprocal of tangent is cotangent, you would flip that one. So those are what you need to remember for this entire first section here. And then you look and see what you have and what you need. You have x and y here. Depending on the trig function, if they had asked for tangent or cotangent, I wouldn't have to calculate anything. I would just literally give the fraction and simplify it. But in this case, they've asked me for a trig function, specifically secant. They've asked me for a trig function that requires the r. So I need to calculate the r first and then just write the fraction. So I'm going to calculate my r by saying the square root of x squared plus y squared, which is the square root of 19 plus 81, which is the square root of 100. My r here is 10. So now I'm going to look at secant. Well, secant is the reciprocal of my cosine. So that value, when I give it, is going to be my r, which is the 10 that I just found, over my x value, which is the square root of 19. They have specifically asked for secant. My secant is r over x, so I put r over x. Obviously, I want to simplify this. So I need to multiply. If I could reduce, I would. The other thing I need to do is make sure I do not have a root in my denominator. So my final answer here is 10 square root of 19 over 19. That is the secant value of this particular angle. All right, this says find the exact value. This means I do not want a decimal. All right, this is based off the unit circle. So on your quiz, I believe I actually ask you to give me the reference angle. So your reference angles will always be from your unit circle. They will always be that 30, that 45, or that 60. All right, 30, 45, or 60. The only time that doesn't apply is like for number 10, where they gave you a quadrantal, one that falls on the actual axis. But for your quiz, I'm always going to ask for a reference angle. Remember, we had that chart for 30, 45, and 60. And our entire unit circle was built off of 30, 45, and 60 angles, right? And so all you really need to know is this a 30, a 45, or a 60-degree angle? What quadrant is it in? That's basically what you need to know. And so for this one, what is my reference angle? My reference angle is the angle to the closest x-axis, which means it's this angle here. Well, this is 180 degrees, yes. I went all the way to 225, so how far away from the x-axis am I? I am 45 degrees, okay? 45 degrees. The other thing you had to memorize for this, you had to memorize the sine and the cosine. You can calculate everything else from those two things. Tangent is sine over cosine. Cosecant is reciprocal of sine. Secant, reciprocal of cosine. Cotangent, cosine over sine. Like if you have the sine and cosine memorized, you have the whole thing. And so you do have to remember this from that chart that you got many days ago. Or you can remember it from the unit circle, but those are your sine and cosine of those three angles. All right? And so once you figure out your reference angle, you've got the answer. They want the cosecant of a 45-degree angle. Well, that's the reciprocal of sine. 45 angles are beautiful because sine and cosine are exactly the same. If my sine of a 45-degree angle is square root of 2 over 2, then my cosecant of a 45-degree angle is going to be 2 over the square root of 2. Do you think I'm going to leave it like that? No, I'm not. I need to get that radical out of the denominator. So my cosecant here is going to be 2 square root of 2 over 2. Reduce it one more time. The cosecant is going to be the square root of 2. One more thing I need to consider. What quadrant am I in? What quadrant am I in? Third quadrant. In the first quadrant, they're both positive. In the second quadrant, my x, which is my cosine, is negative. My y, my sine, is positive. In the fourth quadrant, they're both negative. Third quadrant. And in the fourth quadrant, my cosine is positive and my sine is negative. So if this is the reciprocal of the sine and I am in my third quadrant, my answer needs to be negative. Reference angles. This is what we built the entire unit circle over. So you don't have to have the entire unit circle memorized. You can, if you just happen to remember this, the 225, right? Or reference angles help you build the whole thing. You will always have reference angles that come from 30, 45, or 60. Those are your only option for reference angles. So the reference angle here is 45 degrees, and the cosecant is negative square root of 2. All right, that's why you had to memorize that chart. So we graphed the sine function and the cosine function. All right, I'm going to put the little shortcuts over here. So remember, my amplitude, well, first of all, we'll just remind you of what it looks like. A times my function. This can be sine or cosine. All right. So my amplitude is my A value. My period is 2 pi over B. All right. 2 pi over B. And then remember, we have two different waves here. For your sine function, you start at your midline, which in this case is always your x-axis right now because we haven't done any shifting up and down. We will next year. First quarter, you are at your highest value. Halfway, you are back at the middle. Third quarter, you are at your lowest point and you end back at the middle. That is your sine value. Sine function. Midline, yes. Cosine just shifts it over. So for your cosine, you start at your high value. First quarter, you're at your midline. Halfway, you're at your low. Third quarter, you're at your midline. And you end back at your high where you started. Those are your quarters for these functions. So for the first one, I am going to ask you for amplitude and period. The first one, the amplitude then. The amplitude is the number in front of my trig function. It is just 4. My period here is 2 pi over the number in front of my trig function, which is 3. For period, this tells me where to start and end. So I have a starting point at 0, 0. I need to end at 2 pi over 3. You are welcome to estimate this, okay? 3 pi over 3 would be right here. So what I typically do is I do like common denominators. I know that's what y'all would think to do. Pi over 4 would be 3 pi over 12. This would be 8 pi over 12, right? I'm just getting a common denominator. Pi over 2 would be 6 pi over 12. 3 pi over 4 would be 9 pi over 12. So 8 pi over 12 would be just before 3 pi over 4. That's my ending, all right? So I'm estimating it. I know it is somewhere close to 3 pi over 4 because 3 pi over 4 is 9 pi over 12. 2 pi over 3, which is my period, is 8 pi over 12. Does everybody see what I did? I just got common denominators to try to estimate where I ended that particular graph. So you start at 0. You end at whatever your period is. Your period says 2 pi over 3. You end at 2 pi over 3. Start and end. Mark those. Mark your starting, mark your ending. And then you're going to cut it in half. I'm fine with you estimating halfway. So that's about halfway, right? Does everybody see I just cut my period in half? And then I'm going to cut those in half to get my quarters. So I'm going to cut half and half. So that's the first thing I do. I do starting and ending, cut that period in half, cut those halves in half. All right, I'm just marking my points that I just wrote over to the side, right? I wrote those points over to the side here. I need to know where they are. I need to know where I start. I need to know where I end, my halfway point and my quarters. I need to know those, okay? Now I'm ready to mark my highest and my lowest. Well, my amplitude tells me that. Amplitude is 4. So my highest value here is going to be 4. My lowest value is going to be -4. All right, does everybody see that? Amplitude chart tells you how far away from middle you get. So I marked my highest and I marked my lowest. Now I'm ready to plot those 4 quarters. All right, which function is this? Well, this is cosine, right? It wants the cosine here. So cosine starts at my high value. That's where I'm going to put my first point. I'm starting here. All right, where is my first quarter for my cosine? What did I say was my first quarter? Midline. That's back at my x-axis. All right. Where am I at when I'm at the middle for cosine? Low, which is -4. So I'm going to find that middle point that I've already marked and put it at the low. Third quarter, where am I for a cosine? Midline, and then I end back where I started always. I've marked my values. Remember, this is a wave, not sharp turns. It is a wave, not sharp turns. Sharp turns indicate like an absolute value type function. So you are going to then just curve it. So we're going to curve around, down, and back up. It goes on infinitely in both directions, which is why we need those arrows on the end. That is your cosine function there. That is your cosine function. All right, let's look at sine. 1/2 the sine of theta. So I'm going to do my amplitude and my period. That's what it's asked for. My amplitude is the number in front of my trig function. So what is my amplitude here? 1/2, right? So my all right, amplitude. Amplitude is 1/2. That tells me how high and how low I go. Period. The period here is 2 pi over the number in front of the theta. What number is in front of theta? 1. So my period here is just 2 pi. All right, I've answered those 2 questions. So now I'm going to start at 0, and I'm going to end where? At 2 pi, because that's what my period was. I'm going to cut that 2 pi in half, so that's going to put me at pi. I'm going to cut my halves in half. That's going to drop it here and here. I have my 4 quarters. All right? My amplitude for this one is really tiny, so I'm going to enlarge him a little bit. My amplitude is only 1/2, right? That's what my amplitude was. So the highest I'm going to go then is 1/2. And the lowest I'm going to go is 1/2. All right. Look at your notes. Where do you start for a sine function? Where do you start? You start at your midline. At the first quarter, where are you? Your high value, which isn't very high on this one. Halfway point, where are you? Midline. Third quarter, where are you? Low, which is -1/2. And I end where I started. This is a curve, so I'm going to curve it all the way And I'm going to go a little bit past, and put my arrows. Law of sines. Law of sines says there is a ratio between all of your angles and all of your sides. So we know Pythagorean theorem and SOHCAHTOA work great for right triangles. But life is not only right triangles, and so these theorems work for any triangle. The sine of angle A over or divided by the side A, which is opposite of angle, will be the same ratio of the sine of B over B, and the same ratio as the sine of C over C. Uppercase is angle, lowercase is side. So they want me to solve the triangle. That means I need all the sides and all the angles, right? So I need the measure of angle A. I need the measure of angle B. I need the measure of angle C. I need side A, side B, and side C. All right. In order to use law of sines, I must have an angle and the side opposite, which I do. I have angle C and I have side C. I need to solve for, first, the one that I have another piece of information about, which is B. So I have side B, I need angle B, and I'm just going to set up this ratio. I'm going to say, well, the sine of C, which is 118, sine of C divided by the side C should equal the sine of B divided by the side B. How do I solve for sine of B? Multiply both sides by that, 12. All right, now, I'm going to move him over. I have 12 times the sine of 118 over 41 equals the sine of B. What am I actually solving for? I need the angle. In your calculator, there is a special button you use when you are solving for the angle. It is the inverse trig, right? Arc sine. So in your calculator, you can do all of this at one time because you are searching for the angle. You can say 12 times sine of 118. This will open, so close parentheses there, divided by 41. You can do all of that in your calculator. So when you round to the nearest tenth, you actually round. Now, path of least resistance. Do you think I'm going to use the law of sines to solve for angle A? Yes or no? No, I'm not. Why am I not going to use law of sines? Because that is not the path of least resistance. What is the path of least resistance? My knowledge about triangles, which is all of the angles add up to 180. So now when I need the measure of angle A, I'm going to say 180 minus the two angles that I already know. All right, and so always use path of least resistance. Now, this is not a right triangle, so I cannot use Pythagorean theorem to solve for that third side. I must use law of sines to solve for the third side, but I needed angle A to do that. So I am going to solve for side A the same way I solved for the angle B. But I'm going to I'm going to reciprocate my ratios, which is fine. All right. I'm going to say side C, which is 41, over the sine of C, which is 118, equals side A, which I do not know, over the sine of A, which now I know. All right. The reason I put that on top is because it's easier to solve for what's on top. All right. This time I don't need to use inverse trig functions because I am not solving for an angle. I multiply both sides by this sine value, and I'm going to see that A equals the sine of 47 degrees times 41. Make sure you close parentheses after that sine, divided by the sine of 118 degrees. Tenth, it actually rounds, and you should get 34 there. You have solved your entire triangle. The reason I can't use law of sines here is I have no angle whatsoever. So I have to solve for at least one of the angles. Then I have all three sides. I can do law of sines, right? So at most, you'll have to use law of cosines one time. All right, so law of cosines, and I'm going to write it with the A, B's, and C's, but it doesn't matter which one you use as long as the side that is by itself is with the cosine. So in this case, it's a squared. One of your sides squared equals the other two. This looks very much like the Pythagorean theorem at first. Then you do minus 2 times those sides. And then the cosine of the angle you started with. So if I started with A needs to be here, and these need to be the other two. If I started with C needs to be here, and these need to be the other two. Okay? So in this case, it doesn't matter which side you start with. We can start with A though. So we'll say when I plug that in, 18 squared equals the other two sides squared minus 2 times the other two sides times the cosine of the angle that I don't know. The rest of this is just basic algebra up to a point. All right. So if I'm trying to get this guy by itself, I'm going to subtract these two, right? So I have 18 squared minus 24 squared. This is just literally algebra. I'm just adding stuff over. Equals negative 2 times 24 times 26 times the cosine of A. What else do I need to do to get cosine of A by itself? I need to divide, right? Divide by this whole crazy thing. I'm showing you this because I do all of this in my calculator at once, by the way. So I'm going to show you how to do it all at once. All right. Now, I have cosine A by itself. What am I solving for, though? Angle A. Yes, angle A. So in my calculator, I'm going to do this whole crazy thing using that trig function. All right. Pay attention to order of operations. Your calculator will always do order of operations. If I need that numerator to add and subtract, I have to force it with a parentheses. Yes? So in my calculator, it's going to automatically open this parentheses. When I do cosine, I need to open another one to put this 18 squared minus 24 squared minus 26 squared. Close that parentheses. I need to divide. I need to force the denominator to stay together too. So open parentheses, negative 2 times 24 times 26, close, close. All right. Order of operations is something you cannot forget because your calculator will always do it. So when I need a numerator add and subtract, and I need a denominator to multiply and divide, and I need those two final numbers to divide, I need to force parentheses around it. I need parentheses here. I need parentheses here. Okay. When you do that, you will get the angle A, and they want you to round to the nearest tenth, and mine is rounding and rounding. So what do you get when you put all of that craziness into your calculator? All right, so the measure of angle A is 42 degrees. I now have this guy, 42 degrees. Do you think I'm going to do law of cosines again? Do you think I'm going to do that hideous thing again? No. What am I going to do now? Law of sines. Absolutely. So now I can go straight to law of sines. The sine of A, which is 42 degrees, over the side A, which is 18, equals the sine of B, which I do not know, over the side B. Multiply both sides by 26, but what function in my calculator am I going to use since I'm solving for the angle? The inverse, the arc sine there. So I'm going to say inverse sine. I multiply that 26 over, so 26 times the sine of 42 divided by 18. What is angle B? What is angle B? B is 75. Now, do you think I'm going to use law of sines again? No. What do I need? I need a third angle in a triangle, and I have two of them. How do I find the third angle in a triangle when I have two of them? They all add up to 180. Path of least resistance, always use the path of least resistance, 180 minus my other two angles. What is the measure of angle C?